Hello everyone, today we're looking at the method of dividing decimals by integers and also by other decimals. Now to do this we're going to first start by looking at what happens when you divide a decimal by an integer, and then we're going to move on to the other steps when we have decimals divided by other decimals as well. And in front of us we have two examples here of the value of 2.7 divided by 3 and the calculation of 1.5 divided by 2. Now in both of these scenarios, 3 is less than 2.7 and 2 is less than 1.5. That means our answer is going to be less than 1. Now whenever you do any decimal division by an integer, we simply do our normal division via the bus stop method of 3 into 2.7, and we say 3 doesn't go into 2, so we put that at 0, we have decimal point from above, and then we look at 3 into 27. 3 into 27 is 9, leaving us with a value of 0.9. So 3 into 2.7 is 0.9, 0.9 times by 3 is also equal to 2.7. Now we're going to follow the same process for 1.5 divided by 2. Once again, we are looking at how many 2's go into 1.5. Now 2 doesn't go into 1, so we put down a 0. Decimal point is kept in the same place. 2 goes into 15 7 times. 2 times 7 is 14, meaning there's 1 left over. Now that 1 left over has to go somewhere else. So we just add a 0 at the end over here, and we say 2 into 10. 2 into 10 is 5. And we can see here 2 into 1.5 is equal to 0.75, or 2 times 0.75 is equal to 1.5 or 1.50. And that's our method when we're dividing decimals by integers. Now what happens when you bring about a decimal being part of the division instead, as we have in this example over here? We have over here 2 divided by 0.4. Now what we're looking at is how many 0.4's go into 2. So we could actually write out our 0.4 times table, which is the same as the 4 times table effectively. 0.4, 0.8, 1.2, 1.6, and 2.0, because it's gone in 1, 2, 3, 4, 5 times. But that won't always work, and it's quite long-winded to do. So we need another method to make this easier for ourselves. And the method we use is based along the lines of equivalent fractions. What I'm going to do is I'm going to write 2 divided by 0.4 as a fraction, with 2 as a numerator and 0.4 as the denominator, with this line here, the vinculum, means divide. So when we're dividing values normally, we saw previously that we can't divide by a decimal. It's not something we know how to do. We know how to divide by integers. And the way to make the denominator here an integer is to multiply it by 10. But if I multiply my denominator by 10, I have to also multiply the numerator by 10. Therefore, if we now multiply these values by 10, we get 20 divided by 4. 20 divided by 4 and 2 divided by 0.4 are equivalent fractions. They are exactly the same. That means that my final answer here is going to be 20 divided by 4, which we know is equal to 5. And what's key to take away from this is that whenever you're doing a division with decimals, you need to make sure that the denominator must be an integer. Denominator must be an integer being a whole number. So we're going to apply that to a few other examples over here. So we said key point, denominator must be an integer, and we have 2 examples coming up over here. Here are our 2 examples: 8 divided by 0.05 and 0.12 divided by 0.3. So if we look at the scenario on the left-hand side, I'm going to show us the method which we're going to follow for this process. The first thing we did is we expressed our value as a fraction. We said this is going to be 8 divided by 0.05. We then went about this via making the denominator an integer. So in this case, we have to multiply the denominator by 100 and also multiply the numerator by 100. That gives us 800 divided by 5. Now, if we do this via long division, as we saw in the first example, 5 into 800, 5 into 8 is 1, leaving us with 3 remaining. 5 into 30 is 6, with 0 remaining, and 5 into 0 is 0. So what we have here is that 5 into 800 gives us a final answer of 160. That is our final answer over here. We're now going to look at the question on the right hand side, and we made a very, very key point in that previous question, is we said the only thing that needs to be an integer in this case is the denominator. The numerator does not need to be an integer. We saw in the first couple of examples that the numerator was a decimal and the denominator was an integer. This as a fraction, which is 0.12 divided by 0.3. We then said we need to make the denominator a integer. We can do this by multiplying the denominator by 10 and the numerator by 10. So 0.12 times 10 is 1.2, and 0.3 times by 10 is 3. We are now going to use our long division to work out the value of 3 into 1.2. 3 does not go into 1, goes in 0 times. 3 into 12 is 4 times, and that is our final answer of 0.4. So for all of these questions, we follow the same process. We've made sure the denominator is an integer, either by multiplying the denominator by 10 or 100, or in some cases it could be 1,000 or any other multiple or factor of 10 in that sense. So what we're going to do is we're going to look at one final example with numbers that are a little bit more awkward, but just again giving us a good process of what to do for these questions. And that example is over here. We have the calculation here of 0.377 divided by 0.13. And the key thing to take home from this, as we said, is that the denominator must be an integer. Now, for this, to make this an integer over here, I can't times it by 10 or 100. It needs to be multiplied by 1,000. And same thing over here, 1,000. That's going to give me as my numerator a value of 377 divided by 13. Now, the reason I've used 13 is because most people aren't comfortable with a 13 times table or any other obscure times tables. When you've got a question like this in a non-calculated paper or a non-calculated question, it's good just to list the times tables of the 13 times table, so we can, or whatever the denominator is, so we can do this in a much easier fashion. If I write down 13, 26, 39, 52, 65, 78, 91, 104, 117, and 130, we now have our full 13 times table available to us when we do our long division. That's exactly what we're going to do just now. When we apply the process here of 13 into 377, we can see over here 13 doesn't go into 3, it does go into 37, 1 twice, 2 times, And 13 times 2 is 26, meaning we've got a remainder of 11. 13 into 117 is 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So our final answer here is equal to 29. But we've seen here, we've followed the same process throughout. We've expressed our calculation as a fraction. We've then multiplied the numerator and the denominator by a value to make the denominator an integer. We've then done our division and then obtained our final answer. That's all it is to it. I hope it's made sense. If it hasn't, please let me know in the comments below or drop me a message. Take care. Thank you.